So if the given statement is not in if-then form, rewrite it. We call that writing the conditional, okay, if-then form. Uh, then write the converse, inverse, and contrapositive, and determine the truth value of all four statements. So anything that's false, give a counterexample. The first one, pianists are musicians. So you would say that as a conditional if-then statement. If a person is a pianist, then they are a musician. Okay, that's how you write it. And let's think about that. If a person is a pianist, then they are a musician. And let's determine that. Um, yeah, I mean, how can you be how can you be a pianist as a piano player? How do you play the piano and you're not a musician? So if a person is a pianist, then they're a musician. That's true. That's just true about it. Okay. Now, the converse of that is to switch the order. So if we're saying if a person is a musician, then they are a pianist. Okay. Um, Now, in order to be a musician, do you have to be a pianist? No, that's false then. Give an example. You can be a guitarist. Okay. Now, to write the inverse, you have to go back to the original statement, right? The original conditional, and we negate them both. So if the original says, if a person is a pianist, then they are a musician, we're going to say then, if a person is not a pianist, then they are not a musician. Okay? If a person is not a pianist, then they are not a musician. Think about it. Um, well, you might not be a pianist, but you play the guitar, just like the last example. So that's false. A guitarist. Notice something that's true about these is that if you can find a if you can find a counterexample for the converse, you can use the exact same counterexample for the inverse. And it's the same thing with the conditional and its contrapositive. Okay, a counterexample for one will work as the counterexample for the other. That's how these work. Okay, so look at the contrapositive. Well, we're looking at the conditional and seeing that that conditional statement was true. So guess what you can guess about the contrapositive? Okay, contrapositive, which by the way is reversing their position, since person is a pianist is in front. That would then, and musician is second. We'll now have musician first and pianist second, like the converse, but we now need to negate it as well. So instead of having just their position switch like this one, person is a musician and they are a pianist, we have to negate them. So if a person is not a musician, then they are not a pianist. Okay, well, if you're not a musician at all, there's no way for you to be a certain type of musician, which a pianist is. So that's true that if a person is not a musician, they're not a pianist. Okay? Now, odd natural numbers less than 8 are prime. So the conditional is if an odd natural number is less than 8, and what are we talking about here? Odd natural numbers that are less than 8, 1, 3, 5, and 7, because the natural numbers are the counting numbers, 1, 3, 5, and 7. Then it is a prime. Well, of those numbers, 1, 3, 5, and 7, are they all prime? And actually, 3, 5, and 7 are, but 1 is not prime. If you're not sure why that is, I can talk to you about that really quickly, just because it's an interesting thing to discuss. In order for something to be prime, it has to have exactly 2 factors. So let's say the prime number 2. Okay, there's exactly 2 factors, 2 things you can divide it by that will leave you with a whole number answer. You can divide it by 1, you can divide it by 2. Okay, the number 5, let's say, has 2 factors, 1 and 5. In fact, they all have, let's say 7, they all have 2 factors. 1, you can divide it by 1 and get the same number, and itself, you can divide it by, in this case, 7 and get 1. Okay, so the number 1 actually does not have 2 factors. The only thing you can divide it by is 1. Okay, 1 and 1. which doesn't factor tree out like that, like these primes don't either. But it's only got one factor. It's only got one number that you can multiply it, divide it by, and you get a whole number. Okay, and since the requirement for prime numbers is exactly 2, right? Normally 1, and then a second one that is the number itself. The problem with 1 is that 1 is already listed because they all have 1 listed, right? But then you've already named that and you don't name it 2 times. So 1 in itself happens to be the same number, which makes it then not uh, not prime because it doesn't have 2 different numbers that you can divide it by. So there you go. So now you know what primes are. And so if an odd natural number is less than 8, then it's prime. No, because the odd natural numbers less than 8 are 1, 3, 5, and 7, and 1 is not prime. So now the converse, and remember the converse, remember how I switched my Converse sneakers, the order of my sneakers, by stepping my feet over themselves? Okay. You switch the order. So if you say if an odd natural number is prime, then it is less than 8. Okay, that's the converse. What do we think about that? True. If an odd natural number is prime, then it's less than 8. Let's think of all the odd numbers, all the odd natural numbers, 1, 3, 5, 7, 9, 11, going all the way up. Okay? If it's prime, then it is less than 8. Well, there are prime numbers going all the way up. 11, for example, is an odd natural number, and it's prime, but it's not less than 8. And the idea here is for all of these is this. Okay? You're saying if I fit, oops, sorry, if I fit these conditions, right? If I fit this definition, if I can say it's true about this, then I should have to say it's true about this in all cases. Otherwise, it's not a true statement. So, okay, so if an odd natural number is prime, and again, 11, you could say that's true about 11. 11 is odd, it's a natural number, and it's prime. Okay? Then is it less than 8? No, it's not. So even though it fits this first hypothesis, it does not fit this conclusion. And anything that fits the hypothesis but not the conclusion will be a counterexample. Okay? Now the inverse is to go back to the original, and we need to take the hypothesis and conclusion and negate them. So in the original one, it's if an odd natural number is less than 8, then it's prime. So we would say if an odd natural number is not less than 8, then it is not prime. Okay, let's think about that. If an odd natural number is not less than 8, like 11, then it's not prime. That means that there's no prime numbers that are odd natural numbers greater than 8. Well, again, we can use if the converse is false and you have a counterexample, then the inverse will be able to use that same counterexample. So 11 is an example of something that fits the first part, that it's an odd natural number that's not less than 8. 11 is not less than 8. It's a natural number and it's odd, but it does not fit the second part, which says that it would be not prime because 11 is prime. Okay? And finally, what the contrapositive does is it switches their position, the hypothesis and conclusion, and it negates them. So here we have a hypothesis of less than 8, and conclusion is it's prime. So we're going to switch those and negate them. So it's going to say not prime. If an odd natural number is not prime, then it is not less than 8. If an odd natural number is not prime, then it is not less than 8. And again, the counterexample that works for the conditional also works for the contrapositive, so 1 works, okay? 1 is an odd natural number that's not prime, and it says then it is not less than 8, but it is. So 1 is a counterexample. It fits the first set of requirements that it's an odd natural number that's not prime, but it does not fit the second part of not less than 8 because it is. There you go. Hopefully you'll get better at those as you work more of them. I know that was a bit of a long video, but you know, the steps are pretty straightforward. You always have to stop and consider each one individually on its own merits.